So we've talked about the behavior of the climate system, changes in temperature, changes in precipitation, but what people really want to know is, what is this going to do? What is going to be the impact? What's going to happen to me? So in order to begin to try to anticipate what some of those impacts will be, we need to look at exposure and risk associated with climate change. Fortunately, risk assessment is a very well established field that is used widely in the insurance industry, in public health, and disaster risk reduction, so we can draw on a very well established body of science and practice and apply it to climate change in order to see what we know about climate risk. So climate already, with or without climate change, has many different kinds of impacts. It affects where species can live. It affects what kind of socioeconomic activities can be undertaken in certain places. And when we have extreme events, it can cause a wide variety of damages and losses. So more formally speaking, from a scientific sense, we can unpack the causes of these impacts into three classes. The events, the climate in this case, exposure to those events from societal assets or anything else that we care about, and then the vulnerabilities of those assets to the events to which they're exposed. So I'll give you a little desktop experiment that you can try at home, but then don't blame me if it doesn't come out so well for you. So let's say we have a flood, and this is your desktop, and on it you have a laptop, you have important notes, you have pens, other things. You can see already that the impacts of that event on those assets is going to be different. They were all equally exposed. The laptop, very expensive, may be ruined. The pens, probably you just dry them off and they're perfectly good. The papers, damaged but not destroyed. This demonstrates that the outcomes that are experienced are not a function of the flood, they're a function of the vulnerability characteristics of the exposed assets. Now that general reductionist theory of risk and impact can be applied to buildings, it can be applied to economic sectors, it can be applied to people, and that is how risk is assessed, both in those other contexts that I mentioned, but also in the case of climate change. So then, having reviewed the science, what kinds of impacts might we expect to see manifested in different types of geographic regions? So in urban areas, you have large concentrations of assets, so there's a big potential for exposure. Currently, the biggest driver of risk is not changes in the climate, it's growth in exposure because of increasing urbanization, economic growth, population growth, and these drivers mean that when you have an event in a certain place, there is a lot more there to lose than there would have been 50 years ago or 100 years ago. Over time, however, the climate system will begin to become a bigger and bigger source of risk as well. Some of the things that are very certain to happen include sea level rise, for example. As the oceans warm, as the ice melts, the sea level will rise and it will flood low-lying coastal areas. Small island developing states are particularly concerned about this because they have an existential risk if they're completely submerged. The ocean is acidifying because of the absorption of carbon dioxide. This acidification affects coral reefs, it affects marine economies, it has indirect effects on fisheries, and those effects translate into food security risks in some cases. Temperature increases can affect agriculture, and they have direct impacts in the form of heat waves on human health. So one thing that you might just think about in terms of your own personal situation, if you live in the mid-latitudes, for example, look to the lower latitudes, that's what's coming. The temperature gradient between the equator and the poles is decreasing because the temperature at the poles is increasing faster than the temperature at the equator. And this is going to redistribute the global regional climates so that the ones that are further towards the equator are going to spread out towards the poles, and the very cold areas at the poles are going to disappear.